Okay, well, thank you. Thank you for having me here. Paul, I borrowed a couple of your slides here, but that just shows how we're coordinating, I think, between EPA and ERCOT here, you'll say. I'm going to focus my remarks mainly on the air quality impacts of energy efficiency and actually focus on the criteria pollutants and greenhouse gases and how energy efficiency is related to those. Now, there's a lot of other topics that are currently in the play here. Our new mercury air toxic standards, the cross-state air pollution rule, new national ambient air quality standards, and a bunch more. So I'm just recognizing that they're there. Maybe we can talk if there's questions, but I'll focus first on the criteria pollutants. First off, this is where we are in the Southwest with air quality. And there's a number of things I wanted to point out on the map. First off, green is good, and there's only one place that we've got really green levels of ozone out there in southern New Mexico. And then the red is high. That's very much above, that's the counties that is above the old standard of 85 parts per billion. Our current standard is 75 parts per billion. Now you notice that there's several areas that have blue boxes around them. Those are officially designated non-attainment areas where we're working with the state of Texas to develop air quality plans on a 3-year schedule. We're about a year into that right now. But you notice that in addition to those places with the blue boxes, there's a lot of other color cropping up. Some of it is very close or above the 75 part per billion standards. In some places that were once considered fairly pristine, like around Tulsa and Oklahoma City, places like San Antonio and Austin and Longview and Beaumont, which had, Beaumont Port Arthur had improved their air quality dramatically. And in the last year or so, especially with the hot summer we had, they're seeing problems again. So there are, those communities are very much interested in doing something about that, and I'll talk about that in a second, even though they may not be officially non-attainment at the current time. A lot of this involves power plants and, of course, efficiency of the grid, efficiency of generating electricity. And power plants seem to attract a lot of attention from EPA in terms of regulations, and that's because, well, gosh, they have so much of everything. They've got the mercury and chromium and high NOx emitters, et cetera. And we also recognize that about 50% of the coal-burning units we have are now over 40 years old, and 40% of them don't really have modern controls yet. So there's a challenge, and then that will be playing out as we develop these air quality plans for Texas and the Southwest. Now, Paul, here's your demand. That famous one, that was borrowed from last year's presentation by Trip Doggett. But Paul mentioned that price was a factor. It sure was when we had that high day last year. The price of electricity really skyrocketed. But I think for us, this is another curve that is based on that kind of a demand response. We've had this around for several years. Has anybody seen this one before? Good, a couple have. All right, that's, yeah. Well, what happens is that when you're generating electricity, you're also generating emissions of NOx. And you can see that, of course, the green band, that's from the power plants. They're much bigger than just the generation part because they're a little dirtier. But we also see there's this huge spike in the natural gas emissions, and that just matches the power curve. But actually, when you compare these curves, you find that there's a steeper curve of increase with the natural gas power curve. That's because as natural gas units come online, they're responding to price, of course, but usually the generators will hold off on putting online the less efficient units because they take more energy to get $1 back in profit. So they reserve those for when the prices are increasing. But what happens is that those are also the dirtier units. So there's a real incentive environmentally in terms of air quality for doing something about that peak. either flattening the peak or shifting it to other time periods. And I borrowed another one, Paul, thank you. But this just illustrates the point, is that, again, this idea about demand response, especially since that peak is being caused predominantly by residential customers. Now, I mentioned non-attainment areas. There are a lot of areas that are not non-attainment that are developing plans as well, too. And these are just an example here of some of the ozone advance areas. And these communities are seeing the air quality deteriorate. They don't want to be non-attainment, so they're developing and working with EPA to try to develop plans that include things like energy efficiency and incorporating demand response into some kind of a package that improves their air quality and keeps them improving. In addition to these areas, we also have Longview and Beaumont. Those are those orange areas that I showed on the first air quality map. We're trying to help these communities develop ways to deal with their planning. And this is an example of one it's being developed now. Actually, our folks in Oklahoma used it. It's not that there's nothing in Texas. They're just not counting on ERCOT. So you take ERCOT out, and you're left with looking at impacts that are in the other power grids, most of the Southwest power grid. And what this tool does is it gives you a forecasting mechanism to see if you have a certain percentage of efficiency that you would place on, say, commercial institutions or on residentials. It would give you an idea about what kinds of air quality benefits it would accrue in various areas in the state. So Oklahoma used this to try to take a look at some legislation to see whether or not a 10% or 20% increase in energy efficiency, how that would benefit air quality. And in this case, the benefits are the darker you get. So we're going to be having webinars on this. This tool is still a little bit under development, but we're trying to make it available to work with states and communities in getting a better handle on their emissions and energy efficiency. Oh, okay. Let me talk a little bit about greenhouse gases. There was a tremendous battle. EPA was sued finally over whether or not greenhouse gases were regulated under the Clean Air Act. They are. It is a pollutant, and so we had to act and develop some requirements under the statute for greenhouse gases. And the basic approach for greenhouse gas pollution control is really through energy efficiency. And so we passed requirements both for the transportation sector as well as the traditional power plant or smokestack sector. So just to give you an idea, on the transportation side of the house, we'll have light-duty trucks now getting 35 or miles per gallon or better in the 2012 to 2016 time period. It really has tremendous cost benefits, and it also has, of course, strategic importance. It really reduces the oil, but it also has huge emissions reductions of greenhouse gases. And they're basically approaching this through getting more efficient in the way we drive our vehicles. On the smokestack side of the house, and I'll talk about Texas. Texas did not believe that it had the authority to issue pre-construction greenhouse gas permits. So EPA is the permitting authority in Texas until we can get that fixed. We're working with the state to do that. But what that means is that there's a dual permitting programs operating in Texas now. For major sources, you would need to get your criteria pollutant pre-construction permit from Texas, TCEQ. The greenhouse gas permit would come from our office in Dallas. Nationally, there's about 158 PSD permits, 48 have been issued. In Texas, we've had 35 applications so far. That makes us, I think, the largest state largest greenhouse gas permit program in the country. Other states have less than that. We are just now rolling out a lot more permits that are been in the pipeline. We've had about 4 issued to date, and there's 5 more out for, well, you can read the statistics. So it's coming. We still have a backlog, partly because getting a federal permit means that you have to also take in account considerations of the Endangered Species Act. If it's on coastal waters, then you have fisheries impacts that need to be considered. So it's a little harder to get the federal greenhouse gas permit. But we have a 1-year timeline that we're trying like heck to meet, and we're basically doing that pretty much. There may be an outlier or two. Now, the basic thrust of these greenhouse gas permits is to take a look at large greenhouse gas emitters and look in terms of what's the best energy efficiency that you can achieve with that particular type of a process. And actually, through this analysis, we're seeing that we're getting somewhere in the order of 5 to 10% increased efficiency in the new facilities that are getting permitted. And the kinds of facilities we're talking about, yes, they include power plants, but it's also ethylene plants. There's some huge compressor stations for the natural gas. There are chemical plants. So there are a wide variety of different industries. And they're all looking at energy efficiency to see if that can be called best available control technology. We've got a problem initially with a lot of our applications were incomplete, and we're approaching that by going out and talking with the different sectors and requiring upfront meetings. But what does that mean? Well, first off, here's a case in point that is a permit that isn't, and I'll explain that in a second. We're looking at energy efficiency, and one of the first permits that was issued in the country for greenhouse gases was in Louisiana for a steel mill or an iron plant. I mean, this facility had initially proposed to build a traditional pig iron plant, which included coke oven batteries, blast furnace, cinder plant, the traditional type of structure. There were problems in its permitting, and it was challenged. So they went back to the drawing boards, and by this time the PSD greenhouse gas permit requirements were in place. They looked at their process and came up with a different process of producing iron in a direct reduction process. That permit has also been challenged, by the way, so this is all just theoretical. But what I think is important was the comparison between the two. They're producing about the same amount of pig iron, but when they used the change in process to go for a direct reduction, which was much more efficient, it's about 18% more efficient than the other, the traditional processes, they had a huge decrease in carbon emissions, 5 to 3.4 tons, but also had a huge decrease in a lot of the traditional contaminants as a side result. I mean, that was not in their intended result, but it certainly helped their emissions profile tremendously. As I say, there is still litigation about this, and we'll see where we go with it. But I know that the company was also looking at an even more efficient process than the direct reduction process. Another concept, too, that comes out when we're looking at the permitting is the combined heat and power is inherently a much more efficient way of getting energy and using the fossil fuels. And a great example of that, of course, is the Texas Medical Center here in Houston. And they've had, it's fairly large, 48 megawatts, but they have huge decreases in criteria pollutants as well as large reductions in carbon emissions. Well, okay. So with that, I'll conclude my talk here and be available for questions in a little bit. So thank you.